Hello, and welcome to 5 Minute Math. Today we are looking at the 7th grade concept of predictions from simple experiments. This is Readiness Practice 7.6H, the intermediate version. If you are interested in exploring the 7.6H Readiness Practice for the proficient or advanced versions, or the Readiness Practice resource along with any other standard, you can find those by using the link in the video description. So a survey was given to 150 students about their favorite food, and we see all of these responses here from pizza all the way down to other. Now we've got two questions to answer with this. So let's start with the first one. If a student was randomly selected using the results from the table, the student is equally likely to prefer pizza to which two foods? All right, so where's my pizza? My pizza is right up here, 45. So I'm looking for a combination of two foods that equal 45 because it has to be equally likely. So 45 equals what plus what? So I could do, let's see, I could do a 30 because I see a 30 and a 15 right there. But sometimes there's more than one answer. Let's double check. 10 would have to have a 20. Now that'd have to have 20. 10 would have to have a 35. So we're not there. 8 would need a 37. 20 would need a 25. 6 and 7, there's nothing large enough. 9, oof, nope, that would need a 36. All right, so that was it right at the very beginning. Pizza would equally, uh, the chances of choosing pizza is the same as equally likely as choosing, let's put the name of our two foods, chicken nuggets and pasta. All right, because we took the 45 and we needed to find two other results that were equal to that. Let's look at our next question. So our next question states, if a student is randomly selected using the results from the table, the student is 5 times as likely to prefer what type of food as hamburgers. Okay, so where's my hamburgers? My hamburgers are right here. Okay, so something is going to equal 5 times my hamburger. Well, what's 5 times my hamburger? If my hamburger is 6, 5 times that is going to be 30. Therefore, we're back to chicken nuggets once again. So all we had to do is interpret that as 5 times my hamburger, and my hamburger was 6, and 5 times 6 is 30. Therefore, we're looking at chicken nuggets. All right, so our second problem has a new different table. Students rolling a standard six-sided die 15 times. Here are the results. All right, now based on these results, the student is equally likely to roll a 4. So let's look at 4. The student rolled a 4 times. As to what two numbers? Okay, so now I need 4 equals blank plus blank. Well, we do have a hint here. There are several possibilities, right? Because I could do a 1 and a 6. Now, this is based on the experimental results, right? Not necessarily the theoretical probability. This is based on what actually happened. So I could do a 1 and 6 because 2 and 2 make 4. But I could also do, look at this, 3 and 1. I could do a 2 and 3 because my 3 and 1 make 4. So I can say 2 and 3. And there's another 3, right? I could also bring up this 3 with this 1. So I could do a 5 and 3. Now, based on these experimental results, these are the only options that are going to get me the same number as my 4 outcomes, which happen to be 4, as if I were to roll two other numbers, 1 and 6, 2 and 3, 5 and 3, because they all make 4. Now, based on these results, if the student continued to roll the die, I wanted the outcome 6, a total of 6 times. So my outcome right now of 6 is 2 times. I want to get that up to 6 times. Okay, so how many more times would I need to do that? Well, I could think of multiplication, right? So 2 times what equals 6? Well, my missing number here is 3. So if I were to get the same results for 6, a total of 3 times, I would then get up to my 6 times that I'm looking for. But that doesn't just mean I roll it up 4 more times. In order for the student to get 2 results of 6, they had to roll 15 times. So if I wanted to get my outcome of 6, a total of 6 times, right, I would need to triple the frequency, which means I would need to triple the number of rolls. So it would need to be 15, and I would need to triple that, and I would get 45. So if I tripled my number of rolls, 45, I should triple my number of sixes, which would go from 2 all the way up to 6. So 45 rolls should give me that. That's a lot of rolls to get to the number 6 times. For number 3, we've got a spinner. So we're going to look at probability on a spinner. Each of these are equal sizes. We've got rhombus, we've got triangle, we've got circle. Now, we need to write statements here, okay? So I'm probably going to just give myself a little bit of extra room. And let's write these down below, okay? And let's do them in 2 different colors so it's easy to keep track. All right, so I'm going to do this. What is the likelihood of landing on a rhombus as compared to landing on a circle? Well, how many rhombuses do I've got? I've got 1, 2 rhombus, so let's just go ahead and put that here. How many circles do I've got? I've just got 1. 1 circle, and then we might as well finish it out. I've got 3 triangles. All right, so I've labeled it. 1, 2, 3. Now, what is the likelihood of landing on a rhombus? Well, is it more likely, is it equally likely, or is it less likely? Well, there's 2 rhombuses, and there's only 1 circle. So we will say you are, I'm going to say more likely, because there are 2 rhombuses, to land, and then we just have to put our 2 shapes on a rhombus than a circle. So we're going to compare these two, and our keyword there is going to be more likely. So let's put a circle. I'm going to go ahead and just put a little box around that. All right, so that's pretty simple. Let's do a different color for our second statement here. Write a statement describing the likelihood of landing on a circle as compared to landing on a triangle. Well, I've got 1 circle and I've got 3 triangles. So the order matters. So my circle is less than my triangles, so I'm going to use less likely. You are less likely, and then the rest is the same, to land on a circle than on a triangle. And that is going to be the statement we need for our second sentence, and I'll put a little red box around less likely. That's our keyword, and that's it. If you're interested in exploring the 7.6H readiness practice for the proficient or advanced versions, or the readiness practice resource aligned with any other standard, you can find those by using the link in the video description.